Welcome to ThinkTech Hawaii Business Education Spotlight. My name is Alice Li Hagan. This is a weekly conversation with inspiring educators, up-and-coming leaders, as well as fascinating people who contribute to the social, economic, and cultural well-being of our state. Now, we all know that STEM, which stands for Science, Technology, Engineering, and Mathematics, is a very important part of study for our young people, well, not only in Hawaii, but all over the world. But how do you actually get them interested in being involved in subjects like that? Well, today we have three guests from Kalani High School who are going to share with us their secrets. And I call that a hidden gem because it was by chance that I met this team and I thought that, well, they really have to be on my show. So here we are. Bryan, you are the coach of the Kalani Robotics team. Yep. And Kevin Williams, you are senior, and you have a title with the group, right?
I would be called a PR analysis.
Yeah. PR, so public relations, yeah. Okay. And Darius?
I'm actually the captain of the team.
Okay,
so
wonderful.
I run things.
You run things.
Yeah.
All right, so we need to find out more about what things you run.
All right.
Really great to have you here, and I am, well, as I said, I am excited about the things that you're doing, and I think more people should know about it. So first off, Team 3008 and the, I guess, a little bit of the history of the team. Bryan, tell us about that.
Yeah, so our team number 3008 was randomly assigned to us when we first started with robotics. Okay. And the team number indicates how long you've been with the program. The higher your team number, the younger your team is. The lower your team number, the older your team is.
Okay, so what's the highest number right now?
The highest number, we are now at 6,420, right around there. And that's where the numbers are growing from that point.
Okay, so you're kind of in the middle, so the robotics team, how long has it been around then?
7 years, this is our 7th year.
Okay, now I know that you started the team, right? And when I look at the things that you have done and your background, I said, wow, the first word that I thought of was a Renaissance man. If you can believe, well, it's really true because your background is in history, right, and
special education. So I got my first degree in Santa Barbara, and that was in archaeology and religious studies. And then I moved here to the islands, became a scuba instructor, and was like, I love teaching. Let's go back to school and become a school teacher. Okay. So doing that, I ended up getting a dual certification in history and special education.
Okay.
And then along the pathways, I've gotten certified in science and certified in career technical education. Okay. And I teach engineering and run CAD classes and robotics teams and have a lot of fun.
Very good, because we need people like you. And as I said, you run a great team. So let me turn to Kevin and Darius for a little bit. So how did you get recruited to help Bryan out with the team?
So I started my freshman year, and as a freshman, coming into the robotics room and just stepping in, I thought it was a bunch of nerds that I wouldn't fit in. But as soon as I walked in, I met amazing seniors and a wonderful mentor that had crazy ideas, and that sort of reeled me in, and it taught me a lot of things.
Okay, all right, so hold that thought. It taught you a lot of things. Darius, what about you? You're also a senior right now at Kalani.
Yeah, I joined the team as a sophomore, my first year at Kalani High School, and I saw the announcement on the bulletin, the morning bulletin that we have at Kalani. And I was like, oh, cool, robotics team. I was always interested in computers and technology and that sort of stuff, and I kind of wanted to get into that, see what it was about. So then I went in and I started building robots. So that's how I got in.
Okay, all right. So, yeah, Kevin, you were using the word nerd or geeky? I forget. One of those.
I referred the robotics team as nerds.
Okay, so do you still feel the same way?
No, because we do a lot. We are nerds in the sense that we do robotics and we build robots, but it's not just that. We're also in the community, speaking out to the public. We do crazy things, and it's insane of like what we can do as high schoolers. We apply what we learn from our studies and actually do something with it, and that's impacting our world.
That's amazing. the outreach part is what got me, because from the things you do and the catalog that you were just showing us, maybe you can hold it up and share it with the audience. But you do really a lot of programs, not just for the competition, but you do go outside. But it wasn't like that at the beginning, was it?
No, we built it up over time.
Yeah,
When we
do you
first
wanna
got
tell us
started
about
in 2008,
Okay.
we ran VEX program. VEX program is a robot about 18 inches by 18 inches, and it's played on a 12-foot field with one other robot as your partner or alliance, and two other robots as your competing alliance. And you have to move these four 18-inch robots around the field to collect whatever game objects are and put them in the goals faster than the other guy.
Okay.
So it's like, that's how we started off. And then we moved to a program called First Robotics.
Okay.
And First Robotics involved us in a 6-week time period, figuring out a game challenge, then fabricating from scratch a robot that was roughly 5 feet tall and weighed 120 pounds.
Wow.
And manipulate the game field, and it was the size of a basketball court. Now you had 2 other partners on your team, so 3 of you against 3 others on a basketball court with these giant robots moving back and forth. And we had to learn everything. We had no idea what we were doing.
Wow.
And I got kids involved because I was teaching a science class and said, it was biology, and I went, all right, we're doing this robotics, and anybody want to do it? And had 6, 8 kids that decided they wanted to try it out.
Okay,
So we figured it out one step at a time.
so that was at the beginning, right, when you first started in 2008?
Yeah.
So you only had about, what, six to eight kids?
Yeah, 8 students signed up, but 6 that were really core,
Okay.
that really stuck around and made it
And
happen.
so how many do you have in your team right now?
We have about maybe like 25 to 30 dedicated students within our team.
Wow.
Yeah.
Wow. That is an achievement. I'm glad you brought out, well, of course, that's all part of it, building the robots and the first robotic competition. But I know there was a video about Crimson Typhoon. Can you tell us about it so that I can ask my producer to roll it in a little bit? So, producer, could you get the tape ready? Yeah. And yeah, so what is that all about?
Well, Crimson Typhoon.
So Crimson Typhoon is the name of our robot this year. The game was a cycle rush put on by First Robotics.
Okay.
And that one was basically to manipulate these big storage totes
Okay.
and to stack them.
Maybe the producer, if you could play the tape without the audio, I hope. So Darius could, I'm sorry, keep talking.
Okay. Well, basically we built a robot to allowed us to pick up the totes and
So
stack
like
them.
what they're doing right
Yeah,
now.
like that.
Wow.
Yeah.
So are you given a task to build, you have to build something to specifications to fulfill the task?
Yeah, there's a whole bunch of rules that go along with this game, and with this robot, the main objective is to just stack as many as you can to get the most amount of points. And to get the most amount of points, as you see, they're putting on a container right now. That's the multiplier to get the most points.
Okay. So how long does it take to build something like that?
For us, we actually built it in about 4 or 5 weeks. Yeah, 5 weeks, and then we practiced for another week. Some other teams take the whole 6 weeks or even more. They're still building in the competition.
Where was the competition then?
Our first competition we went to this year was in Australia. So we went to a regional in Australia. We spent a whole week there.
Oh, okay.
So that was fun. Spent about 3 days at the Olympic Center where we had the competition. We went with about 30 other teams. Yeah.
So Kevin, how were you involved in this then?
So in this build season, we have different teams. We have the mechanical team, which is basically the designing of the robot and manufacturing of the parts and then assembling it. And then while they're doing that, you have an electrical team working on the program and just basically the control system to actually bring the robot to life. And funny thing is, usually in our past years, we spent most of our 6 weeks building the robot and giving around one, maybe less than even like a week for the electrical team and programming team to put their electronics, programming the robot. And practice time wasn't existent. So this year we're sort of proud to have our robot fully assembled in 4 weeks, and then programs came in, electronics came in the 5th week, and we got to practice. But then we realized that it's not just about building robots, as I said. It's also about getting into your community and making things happen, giving back to your community. And I sort of participate in the public relations group where we give out presentations, we coordinate events, and it's the students that are actually doing it. It's not our mentors. Our mentors are there to guide us and suggest ideas, but we're the ones putting the work. We're the ones taking the initiative.
So how did you do that? Is it with this particular robot, did you go out and do something in the community?
Yes, actually, one cool thing that we've done this past year is we set up a fundraiser night, or sort of a debut for our robot at the Aloha Tower Marketplace. And it was neat because we had 200 people from the community actually participate in the event, and we gave them food, we showed them what our robot was in other programs, and that just sort of exposes the community to robotics and what you could do with our programs.
Now, Bryan, coming back to you, as a mentor coordinating all these events, programs, activities, maybe focusing on this event in Australia, what was your experience like?
Well, it's an amazing experience being able to travel overseas into a foreign country. So it's international travel. The kids had to learn about getting passports. What do we need to go into the country? What things bring, not bring? What can we do when we're there? Fortunately, Australia speaks the same language, so that helped out a lot in the planning process. But a lot of it I turned back over to the students. And I assigned a student, okay, give us activities we've got to do. Okay, what kind of food things are we looking at? What's the special thing in Australia that we need to try out? Because everywhere we travel, we have to find that special thing in their area to eat and be a part of or experience.
So I guess if I look at the team structure, you're almost like the CEO of the group then?
Yeah.
Okay. So what was the most memorable thing for you for that trip in Australia? Was that the first time that your group went overseas?
Yeah, it's our first international trip.
Okay. So what's a most memorable experience for you? Let's start with Darius.
For me, the animals over there really had an impact on me. We went to, I think, 2 zoos and an aquarium, and they have some really strange animals over there, like platypus and all these night creatures that were really interesting looking, and a lot of different reptiles. I thought that was really interesting.
Okay. What about for you, Kevin?
For me, in general, just going to a robotics competition, it's the people that you meet and get to see. It opens my eyes because Australia has a unique sort of group of people, and they're all sort of our kind, and they help each other. And another thing that that I sort of enjoyed about Australia is that it was their first time putting together a first robotics competition, and we were so glad to have them invite us personally to join their tournament. And when we got there, we had a mindset of winning the Chairman's Award, and that's the most prestigious award given out to a team that is to be emulated. It's a top tier team, and they don't just focus on building the robots. It's also about finding ways to involve your community in robotics. And I was super glad because we actually won that award there.
Wow.
And last year we had a bad year, but this year we were able to bounce back and we got our awards, and we really represented our team, our high school well. And I was sort of just amazed as to what this year brought.
That's great. Now, what about you, Bryan?
For me, it's just being there in the International Theater. There were 6 different countries that participated in the event. I got a chance to volunteer and be a robot inspector and run around and help them with that. It was their first event, so they need a lot of extra assistance. And some of the teams that have been around for 7 years, not a long time, but we have a little bit more experience. It was great to help them. And then the friendship developed with some of those teams that were talking with them and seeing them at championship and going back, hey, how are you doing, Barker? Thunder, how are you guys doing? And going back and forth and building those friendships. That's what the robotics program is about. It's the competition's fun and it gets us involved.
Right.
But it's the stuff we do outside of the competition and getting together, hanging out, having dinners, going to a park and playing around on swings was hysterical, a lot of fun with the Australian team.
You must have a lot of great pictures then.
Oh, yeah.
Yes, quite a few.
Well, I'm glad you brought up the social interaction, because as you all said earlier on, it's not just about building robotics, right? We're coming on a break, but I'd like to come back to that point about the social interaction. And Kevin, you mentioned community outreach several times, so I'd like to come back to talk about what else you are doing to get other people in the community to be excited about robotics. Okay. My guests are the Kalani High School Robotics Team 3008. You've been watching ThinkTech Hawaii Business Education Spotlight. We'll be right back from the break.
Here's the deal. I'm Jay Fidel. I'm the host of Hawaii, the State of Clean Energy, which is the Energy Policy Forum's program on Wednesday. That's how we call Wednesday Energy Wednesday. We call it Energy Wednesday every Wednesday. Are you surprised? Okay, and we try to get guys like Jim Alberts here from Hawaiian Electric who can tell us what's really going on in energy. We want to be informed. It's so important. It's the most important initiative in our state. Clean energy is major, okay? And that's why we cover it on this show. That's the deal. What do you think, Sharon?
I think that's great. That's why we're here every Wednesday from 4 to 5, and we hope you all join us so we can hear people like Jim coming on our show and co-host Ray Starley from Hawaii Energy.
Okay, Jim, you've been here today. You've seen this. You heard what she said. What do you think?
I think it's a tremendous opportunity for people to come together and talk about the issues. Oftentimes there isn't a good forum to bring these key issues out into the public, and this is a tremendous way to go about it. And the activity of this show is essential to keep talking about energy, because as you said, it's such an essential part of our lives that we need to pay attention to it and we need to think about the future.
Okay, Ray, your turn.
Well, this is a special time in the history of Hawaii where we're making some pretty radical changes in the way we use energy and generate energy. And this show is the one place you can count on coming to every Wednesday and hearing something about the latest issues that are on the table, being discussed, that will affect us all going forward. So come join us, and if you have some ideas you want to share with us about energy, give us a call and let us know. We'll put you up here and let you talk for an hour. So come see us.
Thanks, Ray. Thanks, Sharon. Thanks, Jim. It's great to be, from ThinkTech's point of view, it's great to have this show. We love the show. It's our most important show. So come around and listen to us 4 to 5 on Wednesday. Thanks a lot. Bye.
Aloha.
Aloha.
Welcome back to ThinkTech Hawaii Business Education Spotlight. My name is Alice Li Hagan. If you're just joining us, my guests today are 2 senior students from Kalani High School and their coach, Mr. Bryan Silver, from the Kalani Robotics Team 3008. If you have questions, please tweet us at ThinkTechHI. Now, you talked about your experiences in Australia, Crimson Typhoon, amazing things that you're doing. You actually have to fabricate this whole structure to do the task. Social interactions, that's where we ended our conversation earlier on. So let's take that up again. Maybe going back to you, Kevin, I know you're the spokesman of the team. So community outreach, you talked a little bit about that. So what other programs, let me talk about the Proto Lab, and if producer, if you can show us some of the images. Of course, my son came to the Proto Lab again. Amazing things that you put on for the community. So tell us a little bit about that. What is Proto Lab?
So Protolab is a 30-foot container, or actually 40-foot container by around 20 feet. Its main purpose is to sort of involve our community in STEM. But one of the problems of that is we don't have a way to bring that technology and bring the knowledge to our community. That's why we created a trailer. The trailer used to be a music stage, but one of our alumnus sort of repurposed that trailer and made it a STEM center by retrofitting it with equipment such as drill presses.
So that's a good shot of the container. So you were saying that all these equipment in the trailer then. Darius, you've done a lot of programs. Tell us about what you do. Who come to these Proto Labs? What actually does Proto Lab stand for?
Protolab is mainly, it was designed to bring the equipment to the students.
Okay.
For those who don't have equipment at their school, we're very fortunate at Kalani High School to have 3D printers and laser cutters and all that. But some other students may not have it. And going back to your other question, I'm sorry, what was the other question again?
What was I asking?
What does Proto Lab stand for?
Thank you. Yeah, what does it stand
Yeah,
for?
Protolab is a name that we gave it. Originally, we were calling it the mobile solar makerspace because there is solar panels on top, so it is a self-sufficient type of thing off the grid.
So I know that when my son came, he is in Kaiser, so you're obviously inviting a lot of different students to experience the Proto Lab. So how many schools or how many students have visited this trailer of yours?
We had maybe about three groups join, or 4 groups. One was about 10 elementary school kids, one was about 3 or 4 middle school kids from Kamiki Middle School, and another one from Farrington High School.
And of course, Kaiser.
Yeah. So we had
16
them,
from Lahaina.
yeah, and then we had them CAD something, and then we printed it on our 3D printer, and then we had them make something on a program called Corel Draw, and then we cut it using the laser cutter. So they had a little cutout on wood.
Right.
Something.
So I think one of the images had, was it a dinosaur or something that on the
Yeah.
picture? This one here. Thank you.
Yeah,
Thank you,
so
sir.
that one was completely made using the laser cutter. It was a flat sheet and it had all the different pieces, and then it cut out all of those using the laser. And then what we do is we snap those out and then put them together. And I think we hot glued it all together just to stay together, but it all just fits together. Like one of those puzzles you can buy from the store, you know?
Okay.
And that's the cool thing about Proto Lab is that you get to teach these students that are from middle school and elementary and expose them to machinery right before they even get into college. So before they even get into high school, they already know how to use a drill press or the machinery to build their robots. So that's the cool thing about our idea.
Now, what is the whole purpose behind, how did this Proto Lab come about? Maybe I can ask Bryan. Of course, Bryan, you must be really proud of...
Extremely proud of these.
Because I know you can just sit here and kind of observe them, but at the end you play a mentor role.
I make them do a lot of work, but yeah, they learn. They're up there talking. They can take care of it. I don't really have to worry. That's what allows me a competition to go off and play inspector and volunteer, because the kids are good. They know what they need to do.
You've got great
Perfect.
people. You're very humble, but I'm sure that you got to think the big picture and how it all fits into like a puzzle. Now, going back to my question, how
did we all get started?
With the
Several
Proto
years
Lab.
ago, we noticed there's a huge problem here in this state, and a lot of places, in fact, that how do kids get more interest into STEM? How do they get hold of this technology? How do they get exposed to it? And we realized that most schools don't have the funds, they don't have a teacher that's dedicated or wants to spend the time to do it, and they don't have space for it. So we're like, okay, if this is the problem, how can we solve the problem? And our first hit at it was to build a brick and mortar place that people can come to, like a YMCA for technology. And instead of playing basketball, you would build robots. So we'd have like 10, 15 schools come in and different community groups, and they would all build robots. And we'd have one set of tools that everybody got to share, a good set of mentors that everybody gets to share. We thought that would be a great idea. And we wrote a proposal, we sent it to the council members, we talked to a few other groups within our area of how we can find a space. Where do you find a warehouse able to do this? Like, oh, this would work. And we also thought, well, how do we get this out to more people if they can't come to us?
Right.
So we thought about bread trucks and different things of that nature. And through those conversations, we landed upon this huge mobile solar on the center that already had solar cells, had on the batteries. It folded down to a 24 by 24 platform space for a classroom. Like, would you be interested in this? And it was just one of those just things that just meshed together so perfectly. And we're like, absolutely, that sounds fantastic. It's exactly what we're looking for. And it was a lot cheaper to get started than the brick and mortar place. And now we can set it up. So we're in the process of trying to find donors, trying to find sponsors that want to help see this vision take root. And then from there, we want to show up to a community for a month and teach classes after school, teach it to adults, teach it to students, hopefully be at a school, and during the school day, teach CAD, teach with how to use 2D dimensions for cutting out with laser, how to do 3D modeling, and then kind of continue for that. The kids get to make things again. They get that do-it-yourself. And the school gets it, they get to have to play with the tech, they get to learn engineering principles, they get to learn how it would be placed together in that logical step, and they get to play with it. And after that point, they don't have to store it, they don't have to worry about maintaining it, they don't have to worry about trying to get the equipment. It goes away and another community gets a chance to play with it. And then another one, and another one, and another one. And they can hopscotch around and a lot of people get exposed. And we're bringing tech to them, we're not trying to get them to come to us.
Now, I remember when we had that Proto Lab session, this is really a trial run, right? This is, there's a purpose between all these trial runs, and I remember you told me about that. Was it an idea that you're going to present it at a competition or something?
Yeah, so what we wanted right now, we just got this container donated, so we're trying to retrofit it out. We need to put awnings on it so that it automatically comes out and creates a shade platform. We need to change the flooring out so that the carpet in there doesn't get stuck with all of our machinery bits. So, and we need equipment. Right now I'm supplying it with my laser and my 3D printers and the stuff that I have in my classroom, but we want to develop its own equipment in the facility. So it's in a fledgling state, but we wanted to prove that it worked. We're beta testing it right now. We want to see, how do we run classes through? How many students can we have on the trailer without it being too crowded or being unsafe? How many instructors am I going to need? How many tables are we going to have placed in? So that's what our first purpose was, is to beta test it to find out how it's going to work. And then our other resource of why we wanted to do it is because we wanted to present it at Worlds. And I'll let Kevin talk about that.
So,
And World is, can you tell us a little bit about what is World?
World Championship is usually held at the St. Louis, Missouri, Edward
Jones Dome.
And it's a huge dome. This year was neat because you had 600 FRC teams come together and play the game. But we realized that as new teams sort of entered the first program, they're not given certain steps to maintain or build a well-performing robot. And this is the cool thing about Proto Lab. We can increase its functionality by having the Proto Lab have it in other communities. And that is to uplift FRC in the community. And what it does is it gives teams a chance to build well-performing robots by giving them the machinery necessary and the mentors that is needed. And it's not only that, it also helps them with their sustainability. Teams can actually run Proto Lab academies, which is a week class that they charge the community, but they can also write grants to subsidize that cost. And it does outreach and then gives them funds for the next upcoming FRC season.
So you presented this idea at the World, and how was it received?
It was fairly well. Kevin here was on the chairman's team, which is the award. So since we won at the regional level in Australia, we went to go present it at the World Championship. So Kevin was on that team. So what did the judges say, Kevin, about that?
They thought that it was an amazing idea and it would really work out in the FRC community. But then again, there comes the funding, and you need to find the resources to maintain that Proto Lab.
So I guess that's the next step that you're working on. It's almost like a business plan. You have to have all these entrepreneurial ideas to try to move this project to the next step. And that's what I want to ask you a little bit more after the second break. Okay. My guests are the two senior students from the Kalani High School team robotics team 3008 and their coach, Mr. Bryan Silver. You've been watching ThinkTech Hawaii Business Education Spotlight. My name is Alice Li Hagan. We'll be right back.
Ted Ralston, folks, host of our show at ThinkTech Hawaii called Where the Road Leads, where we talk about technology influencing the future of Hawaii. Technology, of course, is the art of solving problems. We always bring in interesting and informed guests who can see from different perspectives and different points of view how that future might unfold and how technology can assist us in getting there. So once again, join us 4 o'clock to 5 o'clock on Fridays. Ted Ralston, your host. And please, if you have ideas that you'd like us to address on this show or folks who you think should be on it, let us know.
Inspired by an ancient culture, classical Chinese dance, vigorous physicality, timeless stories, 5,000 years of Chinese music and dance, Shen Yun presents authentic Chinese culture. Coming to Blaisdell Concert Hall, May 8th and 9th. Tickets at shenyun.com or call 808-792-3919.
Welcome back to ThinkTech Hawaii Business Education Spotlight. If you're just joining us, my guests are from the Kalani High School Robotics Team 3008. So Darius DeSpain, Kevin Williams, and Bryan Silver. Now, you were talking about the Proto Lab, the trailer. It got good review at the World Championship. So now moving the project forward, it's almost like a business that you have to grow. So how is that coming along, and what do we need from the community?
So at this point with the Proto Lab, we already have the trailers, so now we just need to get set up with equipment. We're trying to raise about $110,000 to make all that happen. We're talking with other nonprofit organizations to get that in, maybe about $30,000 from them. So now it really comes up to our community to find other donors and sponsors that want to be a part of this, that really want to give it back out to the community, want to see it hit out there and get kids excited about STEM, get them excited about doing things again with their hands and realizing that tech and hands all go hand in hand.
Because I know this is part of your philosophy. It's not just the theory, but you actually have to do something to remember it.
Absolutely. You don't get those hands dirty, then how do you really know how it works? The book's great, gives you the idea. Now you need to go experiment with that idea, put it to the test. Do you really know how it works?
So going back to the funding part, so it takes about $110,000. You're going to get 30 from grant from one organization, so you're left with about 80. So what happens there?
That's where we start kicking up and looking at grants, and we're going to try to put in for grants. We're asking anybody who wants to be part of a sponsorship into this, donors that want to be part of that organization, part of ImagineWorks. So one of the things we've done is we've actually started our own nonprofit called ImagineWorks. And I've gotten a lot of my alumnus that have come through the program before these guys to help start that. And now as they graduate as seniors, they're going to become in the next group of alumnus that's going to help with that pool. And that pool is going to be growing. And from there, they're going to help run the nonprofit, running the Proto Lab, and seeing that it gets done. And part of the making Proto Lab self-sufficient is it running its own classes. And that these guys become the instructors that teach other people.
Okay. So part of it is teaching the 2D, the 3D, the CAD design and all that. But you also have a summer school academy. Tell us a little bit about that. Maybe Darius?
Yeah, so we have a summer academy that we run every year. We also run it in the fall. It's called Kalani Robotics Academy. So we run 4 simultaneous programs. That would be the WeDo, Lego, VexIQ, and Vex. So there's 4 different platforms for various age groups, from everything from kindergarten all the way through 8th grade. Yeah, so we run that for 1 week every year, and about 3 hours each day. So it's a total of 15-hour class.
Okay. So how long has this academy been ongoing? When did it start?
We started it in 2009, summer. That first summer we opened it up to a Vex class and a Lego class. Then from there, we grew it to 3, then we into 4, and we've actually had 5 and 6, and we mix and matched them a little bit. And this summer, we get fun is we have a G-Tech, which is a girls-only summer camp for 1 week. Girls they went 1st grade to 5th grade are going to learn how to code and program a computer with the Raspberry Pi. And then in the afternoon,
with a what?
Raspberry Pi.
What is that?
It's a small shield. Basically, it's a circuit board that has a microchip on it, and you program that microchip to run code. And it's a 16-bit to 32-bit processor on it. And you just stick it in, you run it, you type in your code, and then you can do a series of activities. So you can make a game, you can make apps, you can make other kind of things. You can surf the internet, you can make Raspberries into TV remotes. So there's a huge variety of things that these little circuit boards can become. It's up to the imagination. So these 1st to 5th graders will do that program in the morning from 9 to 12. Then from 12:30 to 3 o'clock, 3:30, we'll have an older set of group, middle school girls, 6 to 8, that are going to make an interactive musical painting. So they're going to solder nails in the back of a painting. They're going to paint, then put nails into it, then hook that up to a Raspberry Pi and to a speaker. So when you touch different parts of it, it'll make different sounds. So you actually get to play your painting. So that's the other program. And I had 2, a sophomore and a junior girl, both write grants for those 2 programs to get it going. And they're looking for 15 girls in both camps to run for this year.
So how many people have signed up so far for your summer camp? Do you know?
I think we have about
16 total at the moment. And half we do is filled. Lego has 4, and Vex has 4 in it right now.
So if people want to if our audience wants to know more about the program, where do they go? Do you have a website?
I suggest they go to KalaniRobotics.com. And you can look it up, and it's called Kalani Robotics Academy, KRA for short. And that will tell you about all 4 of the programs that we offer for the mixed audiences. And that's in July. It was 13th to the 17th, I believe.
Yeah.
And then we have our G-Tech only for the girls, also found on that same site.
Okay. Now, since you talk about girls, maybe, producer, if you could show the last video. How many girls do you have on your team? You said there are about 25 to 30 core people in your teams.
So a third of that is now that we have girl academies, we hope to see more girl engineers or more girls involved in our program.
Okay. Now, what are some of their experience? I mean, have you talked to them about it? Why did they decide to join? Do they have hesitations? I mean, like this girl, she's actually using tools that I would never even think about, but it's great. How do you get them to do things like that?
First, you're just offering the program and giving the opportunities. And then once they get kind of interested into it, say, hey, we need help with this. One of the pictures you saw up there was one of our students, Junior, and she's welding. She's learning how to weld and put the beads down. And we do a really good job that as we go to build a robot and we do welding, our welding mentor goes, okay, 15 minutes. Danielle, you're up. Darius, you're up. Kevin, you're up. Riley, you're up. And every 15 minutes, it's a new kid learning to weld and lay down a bead and put the robot together. So we make sure everybody gets an opportunity. And we just let things kind of go as they need. And we're saying, oh, we need a machinist to cut this part. All right, here's how you do it. And we run through a safety protocol. We teach everybody how to use the machines. And we set it up so it's not scary. As you mentioned before, I would never touch that tool. But my thing is, you need to touch those tools. You need to learn how they operate. And I don't take the excuse, I'm a girl, I don't do that kind of stuff. No, you're a person, and yes, you are going to do this.
I wish I had a mentor like you when I was going through high school. But that probably is a question for you then, Bryan. Do you notice that there are different ways that you mentor? Do you mentor differently because of, the fact that they are guys versus girls? Or
I don't feel that I mentor any differently for the guys or the girls, but I know I react differently for every student. Each individual I have to react differently to. But I don't think there's a gender bias. I recognize what the individual needs at the time and do my best to try to meet that need. And sometimes I come off a little harsh at times and then come back and smooth it down. Okay, what do we really need? they just take one step at a time. And remember, they're students and they want to learn, and to help them do that.
Okay, so now we're coming to a close on our show, but I just want to ask you, you keep in touch with your alumni quite a lot, even with the trailer. I believe that's because of an alumnus. So tell us a little bit about these alumni, and I'm sure you have interactions with them too, right?
Yeah, so a couple of our main alumni, Grant Takara and Eric Tashima, have been really involved with the program this year. Grant helped us with our robot. He even welded some of it, and Eric helped put together the video, and he helped put together the Proto Lab. Eric's actually been one of the ones mainly putting together the ImagineWorks, a nonprofit organization. So they've been really working hard to make sure that we have that Proto Lab, and we're starting to get our financials a little bit better.
Okay. What about for you, Kevin?
For me, those the people that Darius actually mentioned are the people that I sort of looked up to, and to see Eric come back to the team and just help us out was great, because in our time of need, he was there. He helped us through, and he actually helped the chairman's team present. He sort of solidified our ideas and helped us present. Have all these great students that participate in the team, and you know, graduation comes, they're off to college, and how do you keep them within the team? And that's where ImagineWorks comes in, and our nonprofit organization. It's getting our alumni or our past students back into the team so that we don't lose those amazing individuals.
Now, this is your final year in high school, so where are you two off to?
I am off to the University of Hawaii in Manoa. I'm going to major in computer engineering.
Wonderful. What about for you, Kevin?
I'm going into KCC, so for 2 years I'll be getting my associate's degree in natural science. But it's not that. Over the years on the team, I decided that I love traveling, and to participate in competitions that deal with robotics is amazing because of the people you meet and the things that you can actually create with what you learn in class.
So you would be an alumni soon for the team. So what would you like to continue doing? I'm not sure if Brian has asked you that question, but I can ask it for him. So.
Or as to me, what Bryan Silver told us is focus on our studies first. And once we finish with our studies, or maybe 1 to 2 years into our college, then we can reapply what we learned from our class and then help the team out. As for me, I believe I want to help the team with their financial wise, like getting our sponsors and getting out to the community.
Okay, Darius?
For me, it's kind of, I want to give the students, the new students, the kind of same experience that I had, or I want to provide the opportunity for them to learn what I learned. So I want to try and plan as much as I can within the team, if college allows me to.
Okay, so Brian, you remember that, right?
Yes. Oh yeah, we got their number.
What is your secret? You get all these great up-and-coming young leaders to help you out. I'm just envious, really.
Really? I mean, I found a group of students that weren't willing to say no, and I don't ever say no. An opportunity comes by, it's like, sure, we'll do that. Never done that before. Okay, let's do it. And we've run 5 different robotic programs in a year with these guys. They start their own businesses. We run the academies. We've even created micro toothbrush robots called BristleBots.
Yes.
And that was a product that we developed way in the beginning, and slowly built them from cutting the heads off of toothbrushes and soldering on wires to the motors to actually making our own CAD drawings and then sending it out to a manufacturer and getting our product made specifically to our needs. And since then, we've had 6 generations of BristleBots, and we sell them for $5. They're a great fundraiser. They've helped keep our team alive and able to participate in all these events. We have to raise about $85,000 a year to do what we do. And half of that's for travel, and the parents pick that up, and the other half of that's to pay for tournament entry fees and transport of the robot and get all the parts to build the robots. But yeah, we do a lot. And one of the other things I want to say I was really proud about the team this year is the Real World Design Challenge, which is a CAD engineering program that the kids had this year to do a precision drone that they had to build that would deliver pesticide to crops. So precision agriculture to get chemicals just to the area it needed and not everywhere else.
Wow.
and they won first place this year at the state.
Congratulations.
So they'll be representing Hawaii in the National Theater in October. And Kevin's one of those guys on the RWC team.
Wow. I wish I had another hour to talk to you about all the things that's going on. Very quickly, if something that the community can do for you, what would it be? 5 seconds, please.
To come support us at the Proto Lab and see the Proto Lab running. We want to see Proto Lab at any and every school that wants to have the technology available.
And the website again is?
imagineworks.org for the Proto Lab, and our website is kalanirobotics.com.
Thank you so much for joining me today. Wonderful, and good luck with your competition in October.
Thank you very much. Thank you for having
You've
us.
been watching ThinkTech Hawaii Business Education Spotlight. My name is Alice Li Hagan, and today my guests are from Kalani Robotics Team 3008, Darius DeSpain, Kevin Williams, and Bryan Silver, the coach. Do join us again next week. Aloha. Sorry, Zuri, I went over a little.
Thanks.
What happened?